Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's the only way you can keep me going, refreshed and inspired. Now, if my videos are very helpful and important to your studies, please don't forget to subscribe. By the force method, determine the bar force of member AD. AE is constant. So this is the figure. So let us determine the degree of indeterminacy. So R is, there are two reaction components here. So therefore 2 plus 1 here is 3. Then the number of bars, 1, 2, 3, 4, 5, 6 bars. Then joints 4. So 3 plus 6 is greater than 2 times 4, 2j. So therefore this is statically stable and indeterminate to the first degree. So there's only one degree of indeterminacy, and let's choose AD as our redundant force. And so that we can compute the relative displacement of the joints AD, we apply, because I'm going to solve this by Castigliano's second theorem, let us denote the stress of AD as P. Then we begin at joint, we compute for the reactions. The reactions are, so by the way, the slope of this is 1.8 vertical, 4.5 horizontal, so the common factor is 0.9. So 1.8 divided by 0.9 is 2. 4.5 divided by 0.9 is 5. So therefore the hypotenuse is square root of 29. For this inclined member, these two, as well as AD is same slope, they are same slope. AB and BC have same slope. So vertical 4.8, horizontal 4.5, so common is 0.3. So 4.5 divided by 0.3 is 15. 4.8 divided by 0.3 is 16. So 15 horizontal, 16, then square root of 15 square plus 16 square, so square root of 481. For the reactions, this is 27. So AY, summation moment C, AY times 9 plus 90 times 4.8 equals 150 times 4.5. That's why you get there 27. So therefore this must be 123 upward. Summation forces X, so this is 90 leftward. So I leave that to you. So beginning with joint D, summation forces horizontal equals 0. So SCD times 5 over square root of 29 equals horizontal component of P times also 5 square root of 29. Although it is obvious that they are equal. So SCD is equal to P. Then summation forces Y equals 0. SBD upward equals 2 times vertical component of P because the SCD is equal to P. So SBD is equal to 2 times P times 2 over square root of 29. Then plus 150. So SBD therefore is 4P over square root of 29 plus 150. So take note that we are only interested of stresses of members with constant because remember P is just invented and there's no member AD for the first part because we want to compute the relative displacement between A and D by Castigliano's theorem. So this P here is just invented. Then we proceed to joint C here. So S summation forces vertical equals 0. So SBC times P16 over square root of 481 plus P. SCD is P, so times 2 over square root of 29 plus 123 equals 0. So we can now compute SVD in decimal. Simplifying, SVD is negative 0.5091p minus 168.6. And summation forces horizontal, considering leftward positive. So SAC plus P times 5 over square root of 29, horizontal component of SCD, plus horizontal component of SBC, which is negative quantity negative 0.5091p minus 168.6 times 15 over square root of 81 equals 0. So simplifying, SAC is equal to negative 0.5803p plus 115.312. So I think everything is, we still have SAB. So summation forces vertical at B, SAB times 16 over square root of 481 plus P times 2 over square root of 29 plus 27 equals 0. So simplifying, SAB is equal to negative 0.5091p minus 37.010. So of course this is 90 but not required anymore. You just check equilibrium at A. I will leave that to you, and check equilibrium at B. I also leave that to you, but I'm pretty sure that all these are correct. So remember, we have S in kilonewtons, partial of S with respect to P, then the length in meters, then the product of these three. So we are interested of this 1, 2, 3, 4 members only. So beginning with AB, alphabetical order, negative 0.5091p minus 37.010. Partial derivative is negative 0.5091. The length of AB is square root of 4.5 square plus 4.8 square, not square root of 481. Remember, we just transform the slope so that the horizontal and vertical components would be whole numbers. So square root of 4.5 square plus 4.8 square, that's 6.5795. Then the product after setting P0 is 123.97. Then after AB is AC. And negative 0.5803p plus 115.312. The partial derivative negative 0.5803. The length of AC is 9. And the product after setting P0 is negative 602.24. Then supposedly there's no member AD, remember. So we proceed to BC, and it is negative 0.5091p minus 168.6. Partial derivative negative 0.5091. The length of BC is the same, 6.5795 as to AB. Then after setting P0, the product is positive 564.747. Then BD, you have 4p over square root of 29 plus 150. Partial derivative 4 over square root of 29. Then the length is 3 for BD. And after we set P0, the product is 334.252. So those are the 4 members with constant. So there's a value. Therefore, the sum of S partial of S with respect to P times L is adding all this for 20.729. In the second part, we set P equals 1, and that is SAD. So delta A relative to D is 420.729 over AE. So AD, we remove the loads, same slope, and P is 1 this time. Therefore, SCD is equal to P also. Then SBD would be just 4P over square root of 29. There's no more 150. Then SBC is negative 0.5091 P. SAC is negative 0.5803 P. And SAB is negative 0.5091 P. And remember that AD is now a member, so it is SAD. So there are 6 members, 6 bars to be tabulated in computing FAD due to the unit load. So that would be on the next slide. Let's just copy all these values. So this were the values in the preceding slides. Let's now tabulate. So delta A with respect to D was 420.729 over AE. So we have member S, partial of S with respect to P, length, then the product. So beginning with AB, negative 0.5091 P, then partial derivative negative 0.5091, the length of AB 6.5795, then the product in terms of P, so there is P this time, is 1.7053, and P is 1, so that's why we get 1.7053. Then AC, so negative 0.5803 P, partial derivative negative 0.5803, length is 9, and the product after setting P1 is 3.0307. Then AB, AC, AD, P, so it is P derivative 1, length is square root of 4.5 square plus 1.8 square, that's 4.8466, so the product P is 4.8466. Then BC, negative 0.5091 P, derivative negative 0.5091. The length is 6.5795. The product after setting P1 is 1.7053. Then BD, 4P over square root of 29, derivative 4 over square root of 29. The length is 3 for BD. Product after setting P equal to 1 is 48 over 29. Then lastly, CD is equal to P here. So derivative 1, length 4.8466, set P1, so 4.8466. Therefore, summation of S partial of S with respect to P times length is the sum of these values here in the last column, and that is FAD equals 17.79 over AE. So the compatibility equation FAD times SAD, which is P, plus delta A relative to D, 420.729 over AE equals 0. So 17.79 over AE SAD plus 420.729 over AE equals 0. So cancel out AE. So SAD again is negative, so that means the force is in compression. So solving for SAD, it is 23.65 kilonewtons compression. So that's it for this problem.